Hey, this is Brock Lemires, and we're continuing our study of embedded systems design. We are in the C programming language for the MSP430, and in this video, we're going to look at switch case statements in C. Okay, so let's fire up CCS, and we'll go ahead and do File, New CCS Project, and let's go ahead and call this C underscore switch case main.c. And again, switch case, it's a simple construct. And we don't necessarily care. I mean, we care. The whole point here is we're trying to look at how these higher level programming constructs get implemented as instructions on a microcontroller or any computer. So let's do a switch case statement where we're going to have some loop variable int I is equal to 0. And what we'll do is we'll do another one of these for loops that increments this from 0 to 5 or 0 to 4. And each time through the loop, we'll use a switch case statement and check its value. And so let's have a couple flags, and we'll do like one that's called it is 1. And as we go through, we'll use a switch case statement to say if the value of the loop counter is equal to 1, we'll assert this. So we'll assert when I is equal to 1. Yeah, okay, and then let's do another one, which is it is 2, and we'll initialize that to 0, and we'll do assert when I is equal to 2. And we'll just do 2 cases, but switch case statements are made for when you have a lot of cases that you're checking, and you don't want to do like this never-ending if, else, if, else, if, else, if. It's like, let's just make it into a case statement, switch case statement that's easy to kind of visually see, and you can do a lot of copy paste, honestly. So let's fire this up. First of all, I need an infinite loop because I never want to hit that return 0 and crash my computer. So yeah, I like to leave return 0 in there because it reminds me of not to hit it. You could delete it though. And then let's make a for loop. And then let's do this. We'll go I is equal to 0, redundant again, I is less than 5, and then I equals I plus 1. And what that's going to do is it's going to loop us 5 times. It's going to go 0, 1, 2, 3, 4, 5, and that's it. So we've got it. So what's cool now is I can do a switch statement. So I'm going to go switch, and the input that I want to look at in my switch statement is the variable I. Okay, so then I open up my curly brackets, and there's lots of curly brackets here, and I always put like a extra return in there that I have to take out. That's all right. Okay, so here we go. And the first thing is what I want to do is I'm going to say case, and I'm going to say 1. And that says, if I is ever equal to 1, do this. And well, here's what I'm going to do. I'm going to go it is 1, and I'm going to assert that flag. Okay, so I put a 1 in there. But at the same time, I need to also need to make an assignment to it is 2. And the reason is that we want to have, if I ever set, for example, the flag 2, I would need the next time through, if it wasn't 2, I need some way to put it back to 0. So we're going to have 2 assignments in here. One will assert the flag that we care, and the other one will clear the other flag. And that's to make sure that once it's set, it actually gets reset when it's a different case. Okay, so now let's do a case, and we'll look at, oh, nice indent. So now we'll do this one. Oh yeah, and by the way, you got to tell this thing, oh, I'm done with this particular case, and then you come down here, and I'm going to look for 2. And if the I variable is equal to 2, we're going to go ahead and make sure that 1 gets cleared, and then we'll take a 1 and put it into it is 2. Okay, so I got my 2 flags, and that's the situation. Now, here is what we also have to do. You always need this default, okay? Because what happens when you come through the switch statement and I is equal to 0? Well, it isn't going to take these statements, it isn't going to do these statements, but you need to do something. So we got to have the default in there. And always remember the break. I always forget the break. Okay, so I got my default, and what I'm going to do here is let's just go it is 1. We'll just make that a 0, and we'll do it is 2. Make that a 0, and then brick. And of course, do my auto indent on that, but that's all right. It's all right. It's all right. Oh man, look at that. Okay, so there it is, and that should be it. So let's think about what we just did. Let's make sure we got all our curlies matching. So I got switch right there. I have case 1, case 2, and a default. And then I have my for loop I'm going to go through it and evaluate this switch case statement 5 times and look at I as it goes from 0, 1, 2, 3, 4. And then once I jump out of that, I'm going to loop forever using my while one. Okay, remember, let's turn off optimization or else the friendly compiler will remove all our code because it noticed we aren't accessing the outside world, and it said, man, this programmer doesn't know what they're doing, so it just deletes all your code. So I turn off optimization. That gives me a chance of seeing what's happening, and so go ahead and debug this thing. We got an error, so let's go in here, make sure we got our error fixed here. Okay, so I scroll down here, I see line 23, I was expecting a colon, so it's almost like I didn't put a colon after default. I didn't. Okay, save that. That's all right. And we go like this, and here we go, and off we run. Looks like it's working this time. And what I want to look at is I want to look at the disassembly of this and think about how we originally learned about switch case statements. So let's come in here. We'll put a breakpoint on int and go ahead and run to the first int I is equal to 0. Here I have all my variables, okay, and I have my disassembly window. So if you don't see those, go to View Disassembly and View Variables, and that'll pop up. And here we go. So I'm going to step through and get these all cleared out to begin. So I go step, 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 and now they're all cleared. And those were accomplished using these 3 clears. Look at where these variables are. They're in the stack again, okay? And then what's happening is the stack pointer is pointing to basically an address which it can be used to point to this first one, which is I. But then what it does is it uses an offset of 2 to get to the next variable, and then it uses an offset of 4 to get to the next variable. So, and this is automatic. We don't have to worry about the absolute value of the stack or where exactly these are. It's all handled perfectly for us. And what's even cooler is that we have 3 variables now. We didn't even tell it where to put these. It could have put them in a register. It could have put them in at the beginning of data memory, but it didn't. It used the stack, and we actually don't care. It's nice to know, but the reality is we just let the compiler do it because it can do it better than us sometimes. Okay, so here's this while loop is now starting. The while loop starts with this label right here, and you'll see that we have a jump back to that always. In fact, I can just show it to you right now. The final one down here is, the final one comes down here. You got the switch, you got the not. So here's the end, and it actually put the while label down here. So that's the implementation of the while loop, is it did a jump back to our first label that was automatically generated by the compiler. Okay, so that's that. Okay, life is good. Okay, so let's go ahead. It's going to do the for loop logic now. So it's going to have clears out I, and then it compares it to 5 and makes sure that you should enter the for loop. And in this situation, it is going to enter the for loop. Otherwise, it'd jump out of here. Look at where it would jump. If it doesn't do the for loop, it actually jumps back to the beginning. So life is good. Okay, so here we go. It's not going to take that jump because the for loop variable is equal to 0. And here we go. So it's coming into the switch. And so I have this this switch statement right here, and let's see what the first case is. Okay, so let me step down to the first statement. Okay, so now we're looking at how this is evaluated, and this is pretty interesting. So it's going to do this jump, right? So it's going to come down here, and here's the code that it uses to determine whether this variable I is equal to a 1 or a 2. And you would never in a million years think of this on your own, or at least I wouldn't. The way that it does this is it moves I into a register. So it moved the stack pointer, the value that the stack pointer is pointing to, which is this guy right there, I, into register R15. And then it decrements it. And the logic behind it is you're trying to figure out if this is equal to a 1. So if you decremented that, you would have, it would be equal to a 0 when you decremented it. And then you would essentially, it would say it would be 0. The 0 flag would be asserted. Okay. And so it's like, okay, so it decrements and then it jumps if equal to this label right here, which is going to correspond to the code for this right here. Then what it does is it says if that doesn't take, decrement it again, and it will subtract 1 from it again. So if it happened to be 2, it would come in, decrement it by 1, it would be not equal to 0, so then it wouldn't jump. It would decrement it again, and it would be like, then it would be equal to 0, and then it would jump. So this logic right here is really, it's really interesting logic. It's not exactly what you would think of. Sometimes it'll do a compare. So it'll be like compare 5 to, the variable you're looking at. But in this situation, the compiler actually recognized that there's only 2 values that it can take on. The values come in and they're either going to be, you only care if it's you only care if it's 1 or 2. And so the logic it came up with was nuts, actually. It's awesome though. Okay, so let's watch it. So it's going to decrement it. It is not equal to 0, so it knows that it's not a 1. Then watch this. It decrements it again. Now it knows it's not a 2, so it's going to jump to this label, which is going to be the label for the default. So look at down here. This is the label right here for the default. So I know that it's the default code because here's my C code. This is the label it jumped to. Here's my clear. So you're going to clear the first flag, clear the second flag, and then jump back up to the beginning of the case, or the for loop, and then it does its for loop logic. So let's get through that. The for loop now is a 1. And now here is the first switch situation. It's now going to bring that into R15. Okay, so it's going to bring this value in. And so look at that. I do that. It's going to decrement it. And now the 0 flag has been asserted. So if I go look at my registers here, the Z flag is set now because the I was 1. I subtracted 1 from it, and now it's equal to 0. It's going to jump based on the Z flag, and I will actually go do the code for case 1. So watch this. I'm going to click this. And it comes down here. Look at it. It went down to the case 1 code, which happened to be at label CL2, which shows this case right here. And now it moved a 1 into our variable. So now our variable, it is 1, got asserted. And then it goes ahead and clears, breaks, and it goes back up. And it does the for logic again. So this time it's going to come through as 2. Look at this logic. So now here's the logic. I want to actually see this in the register viewer. So let's look at R15. This is nuts. So I step right here. It brings the value of I into R15, decrements it, says, hey, are you equal to 0? The answer is no. So it decrements it again, says, oh, are you equal to 0? Because if you are, you must have been a 2. So it jumps down to the code now for case 2. And it goes ahead and assigns, let me put the variables back on there. It goes ahead and clears out it is 1, asserts it as 2, and it evaluates the for loop again. So this is, it's awesome. It's weird, but it's awesome. Okay, so that's how it can potentially implement a switch case statement. All right, so you did it. It's very fascinating. So that's it. Congratulations. As always, support my channel by subscribing, and see you.